You ever wonder how websites just know what movies you'll like? Or how your phone can finish your sentences? Well, that's not magic, it's machine learning. And today, we're going to pull back the curtain and see exactly how computers learn to make these incredibly smart predictions. Okay, so let's make this real with a super practical example. Let's say we need to figure out the price of a house. How would you even start to guess the right price? It's a tricky question, right? But it's exactly the kind of question that computers are getting amazing at answering. So let's see how they do it.
So where do we even begin? Well, you'd probably start by looking at its features, right? Things like how big it is, the number of bedrooms, maybe how old it is. And it turns out those features are the exact same clues a computer uses to connect the dots and come up with a price.
All right, so here's our game plan. First up, we're going to unpack this whole idea of learning from examples. Then we'll meet our very first and simplest smart tool. After that, I'll walk you through a super simple 4-step recipe that you can use for pretty much any prediction problem. And to finish things off, we'll take a quick peek at the software toolboxes that bring it all to life. Sound good? Let's jump in.
And that brings us right to the big idea, the real secret sauce behind solving our house price problem. This concept of learning from examples. So this whole approach has a name. It's called supervised learning. And honestly, the best way to think about it is like a student who's studying for a test, but they have the answer key. The computer gets to look at thousands of houses, and for each one, it sees all the features and the actual final selling price. By just going through all these known examples, it starts to figure out the relationship between a house's features and its price. Now, it's not like there's only one way for a computer to learn. Nope. There's a whole toolbox of different models out there. Things like decision trees, neural networks, they all have different strategies. And I know that list might look a little intimidating, but trust me, the best way to understand all of them is to start with the simplest, most fundamental one. Which brings us to our hero for today, the linear model. It's the simplest tool in the box, and it's absolutely the perfect place for us to start. Okay, to get how this works, just picture a simple graph in your mind. Along the bottom, you've got the size of a house, and up the side, you've got its price. Now, every single house we have data for just becomes a single dot on that graph. So, what's the model's job with all these dots? It's actually really simple. Its entire mission is to look at all those points and draw the one single best fit straight line right through the middle of them. That line, that's the trend. It's the pattern, basically saying, hey, it looks like as a house gets bigger, its price tends to go up. And this really cool technique has a proper name. It's called linear regression. Linear because, well, it uses a straight line. And regression is just a fancy word for when you're trying to predict a specific number, like a price, a temperature, or maybe a test score. So why are we starting here with this specific tool? A few really good reasons. First, the logic is something you can actually see. It's easy to visualize. Second, the way it learns just makes sense. It's really intuitive. And third, and this is the big one, the ideas we're learning right now are the building blocks for almost everything else, even those super complicated neural networks you hear about. Okay, so the theory is cool and all, but how do we actually do this? How do we put it into practice? Well, it turns out there's a simple 4-step recipe that works for almost any supervised learning problem out there. It goes like this. Step 1, we split the data. Step 2, we train the model. Step 3, we make predictions. And step 4, we check our work and see how well it did. Let's break each of those down. First up, splitting the data. We basically take all of our house data and split it into 2 piles. The bigger pile is our study material. That's what we call the training set. The smaller pile is the final exam, the test set. And here's the golden rule. The model is absolutely not allowed to peek at the final exam while it's studying. No cheating. Okay, step 2, it's study time. We give the model the training data, and it gets to work. It just starts digging through it, looking for patterns, adjusting its line, making tweaks over and over, trying to find that perfect angle that best explains the relationship between a house's features and its price. And now, the moment of truth. Step 3 is the final exam. We take that test set that we hid away, the houses the model has never seen before, and we ask it, okay, predict their prices. This is how we find out if it actually learned the general rule or if it just, memorized the answers from the study guide. Which brings us to our final step, grading the test. How do we know if it did well? Simple. We just compare the model's predictions to the actual prices. And as you can see, our model isn't perfect, but wow, it's pretty close.
For house A, it predicted $310,000 for a house that actually sold for $300,000. Hey, that's not bad at all.
Okay, so this four-step recipe is great in theory, but how do you actually do this on a computer? Well, for that, you need a software toolbox to bring it all to life.
There are lots of options out there, but two of the most popular are Scikit-learn and PyTorch. Think of it this way. Scikit-learn is like an automated push-button machine. It's awesome for just getting results fast. PyTorch, on the other hand, is more like a clear glass box. You have to be more hands-on, but it's amazing because you can actually see all the gears turning inside and really understand how it's learning.
All right, wow, we have covered a lot of ground. So, before we wrap this up, let's do a super quick recap of the most important takeaways from all of this.
So what do we learn? First, that supervised learning is just a way of learning from examples where we already know the right answers. We also learned that linear regression is our simple starting tool that just finds a straight line to predict things. And remember that four-step recipe. It's always split, train, predict, and then evaluate. And finally, we know that tools like Scikit-learn and PyTorch are what let us actually do all of this.
And all of this really just hammers home why starting here is so powerful. Linear regression is simple, it's easy to understand what it's doing, and it gives you this amazing foundation for literally everything else that comes next in the world of machine learning.
So, there you have it. We've just pulled back the curtain on how a computer can learn to predict the price of a house. But here's the really cool part. This exact same four-step recipe, it works for so much more than houses. So I'll leave you with a question to think about. Now that you know the basics, what's something in your world you could teach a computer to predict?